Come on. Now, what I'm going to talk about today is bipartite graph, and it has come out in the exam quite a few times, this one. So you do really need to know what a bipartite graph is. Pretty straightforward in many ways. If you concentrate and you listen, you will know what to do. If you're not, you will get totally confused. All right? So, bipartite graph. What you need to do today is know the definition and be able to identify one. You should also be able to use it and draw it. All right? Now, let's start to have a look at the graphs here. The three graphs there, you can see that the first two, this and this, you can actually have two distinct groups, correct? All right? This group here, there's actually no edges between the vertices, right? Here, there's no edges between the vertices. Same here, no edges between the vertices. Here, are they? Can I redraw that to look something like this? We don't know yet. We'll see how we could identify that. Graph like this. This is actually a bipartite graph. It's a graph whose vertices can be split into two distinct groups in such a way that each edge of the graph joining a vertex in the first group to a vertex in the second group. So you've got here, there's one group. All right? This is another group here. So group 1 and group 2, what I have done is you've got two distinct groups. You can join them together. All right? So it's also called a bigraph. So that's the definition of a bipartite graph. So each one, you've got one group and one group here. Or one group here, one group here. Now, with the third one, we don't know whether it's a bipartite graph. All right? We'll think about how we could do it. Now, before we try to rearrange the third one into a bipartite graph, let's have a look at where am I? Let's have a look at how we could identify them. All right? So here, what I've done is actually make sure that the two groups have distinct different colors. All right? It can be color coded. If you got highlighter, great. If not, use something like a cross and a circle. It's up to you. All right? Make sure that you could identify them clearly, cross and a circle, because in the exam you probably have black and blue ink, and when they scan it, there'll be just one color. So probably use cross and a circle. This is how you could identify the group. All right, now, see, you can notice that no adjacent vertices are of the same color. All right, so adjacent vertices, you've got two vertices joining one edge. There is no, the two colors are different. Two colors are different, two colors are different, two colors are different. There's nothing between the two rays. Nothing between that ray and nothing between that ray. So like I say, in the exam, use a circle and a cross. All right, let's see how we could rearrange this. Now, when you start looking at this, A, B, C, D, E, and F, what you could do is to start off with color coding, or put a circle or a cross. I start off by anyone, it could be A, and then look at what is adjacent to it. Next to it has to be red, if I started off with blue. And then from blue, it has to be two reds again. All right, I'll go through systematically to show you step by step how to do it in a few minutes. So if I redraw that, you can redraw that into this form. So you've got two distinct groups now, where A, C, F, and H is one group, and B, D, E, and G is another group. All right, two very distinct groups, and it's a bipartite graph. It's quite important. Like I say, I've seen this in exam a few times, so you will have to know this quite well. All right, next. Now, you need to know what a complete bipartite graph is. Again, there are questions that will ask you what a complete bipartite graph is. It's a graph which has every vertex in the first group connected to every vertex in the second group. All right. So, for example, group 1, you know there are 3 in group 1, 3 in group 2. All right. So group 1 will have 3. Group 1, this one will have 3 edges coming out, connecting all the red ones. Here there'll be 3 edges connecting 3, 3 edges connecting 3. All right. Here, that is, you know that there are 4, so there should be 3 coming out from here because there are 3 vertices in group 2, whereas there are 4 vertices in group 1, so there'll be 4 edges coming out from 1. So that's a complete bipartite graph. Any questions so far before I move on to the next bit, identifying it? All right, before that, I've got to go through this first. The number of edges in a complete bipartite graph is given by m times n, where m is the number of vertices in the first group, and n is the number of vertices in the second group. All right, so here, the first one, I can describe this as K, 3, 3. This one could be K, 3, 4, because this could be group 1, this could be group 2. All right, if I write it differently, group 1 and group 2. Or K, 4, 3. All right, if I write that's group 1 and that's group 2. So it really doesn't matter. Here, you can alternate between 3 and 4, 4 and 3. That's okay. Now, each subgroup of a bipartite graph is a graph, is itself bipartite. So if you take some bits out, if you forget about, let's say, this bit, this part, you're going to look at 1 and 2 red dots, you can see that it is actually a complete bipartite graph. All right? That is connected to that, that's connected to that. So there's a subgraph. Every subgraph is of a bipartite graph itself is bipartite. All right, now, let's see, how could I identify a bipartite graph? Like I say, I will start from one node. All right, so if I start from node A, either color code it. In the exam itself, there is no way that you could color code it. All right, so you need to start by putting a cross. A cross on the first one. Show what's happening. Technology. All right. So I'll start off with a cross, or don't like this. I put a cross in A. Once I've done a cross in A, I look at the adjacent vertex. All right. Start off with B. Let's have a look at B. Opposite that, it has to be a different color, so I put a circle around it. All right? A again, opposite A, has to be a different color, so it's E. All right. Now, then I go to B. B to C and B to D. B, C, opposite. If it is bipartite, C has to be a cross because it has to be same as A, correct? And then D has to be the same group as A, it has to be a cross. All right, keep going. C. C to E, yet you know that it's different. One is a cross, one is a circle. So now let's have a look at G. A cross and a circle. Then from here, there's one last bit left, F and G. So if G to F, if it is bipartite, in one edge, the opposite one would be in different group. So I put a cross in. All right, so this is how you could identify one, by putting a cross or circle or color coding. All right, this is how I color coded it. Now, redrawing it, put all the reds together and put all the blues together. So you can start from A, C, F, and D first, or you can start from B, E, G first, whatever way. And then you could draw it, and this is how you could connect it. Any question there? No? This is pretty straightforward. You just need to know how to identify it. Now the next one, Here, I've got extra vertex between F and D. Let's see if it is bipartite, all right? I start with A, circle that. So B, I'm going to put across, correct? E, I'm going to put across. Now from B to C, all right? C, I can put a circle. All right, C to E, E is across, so that's fine. What about C to G? Is across. Now, B to D. B to D should be a circle. D should be a circle, correct? If it's bipartite. And E to D is a circle. Now let's look at D to F. From D to F, if it is bipartite, F should be a cross, correct? But here, what happened here? From G to F, if it is bipartite, it has to be a circle. So this is telling me that it is not a bipartite graph. All right, you can redraw it, but you have a connection between D and F. There is no two distinct group. All right, there is no two distinct group. Although I put that in color, but there's no two distinct group because of that. So you cannot call this as a bipartite graph. There is an H between D and F. All right. Now, testing if a graph is bipartite. Start any vertex and color with one color, or use a marker. All right, a cross or circle, and then color or mark all adjacent vertices with another color or another marker. Keep going until you can find, until you have exhausted all the vertices. If every edge of the graph has a different color at its end, then the graph is bipartite. If not, the graph is not bipartite. So either use a color or use a marker. In the exam, you should be using a marker. Highlighter is fine, but if you really want to indicate to the examiner what you do, always use cross and circle. All right? Always use cross and circle. So I'm going to do a few things. So here, color or marker. Okay? If I start off with a cross, and then I go with a circle, then a cross. Or if I start off with a circle, I go with a cross, then a circle. So either a marker or a color. Doesn't matter. All right? So let's go to the next. Now, is this a bipartite graph? Can you all copy down and try it, please? It doesn't matter which point you start.
Vertex in the first root is connected to every vertex in the second root. Yeah.
Start off with any point, it really doesn't matter.
It is. Here it is. Two groups.
right. Now,
Because
redrawing it,
oh.
you should think about
Ah, yeah. You can't. It's not-
identifying it. You should start off with any one. So I started off with E when I was doing it. It doesn't really matter which one. I started off with E, so I know that C and F, I got to put a cross in because E is group 1, so therefore F and C has to be group 2. All right? So now, then from there, I know that A is actually group 1. Circle. From here, F and D, that is, if there's a cross, there's a circle, and then from here to here. 0 and B and F. So there is actually a connection between B and F.
Okay.
There's a connection between B and F. That is not another, it's not a group. Alright? So there is not bipartite.
Yeah.
That's not bipartite. That's actually not bipartite because of
Opposite. Yeah.
B and F. So you have to connect B and F, so therefore it's actually not bipartite.
You have to
Alright.
make sure you don't have like the
So
same
this is how you
into
identify
the
a bipartite
adjacent
graph.
on one
Now, what about the next one?
edge. If you do, then it's not bipartite.
Alright, try this please. Is this a bipartite graph?
Actually, give me a pen.
Surely, mate. Surely.
Alright, can you all try this?
He's whipped one out from his pocket.
Start off with A, B, C, or D. It really doesn't matter. And if it is, and then draw.
Yeah. It's all you need. You don't want any edges to have the same node. Yeah, because you're meant to have two different groups.
Oh, how was everyone's sleep last night? Good sleep.
Yeah.
That's good.
What happened?
Nothing. Just wondering how everyone's
Sleeping
sleep.
late, eh?
No, I had a good sleep.
No. What time did you go to sleep?
11:30, and then I woke up at 8. It was a nice one.
I feel like I'm getting better sleep now.
Yeah.
Well, if I ask you to do things, please do it rather than keep talking. Thank you.
Because like the lit kids had their they had fucking late.
Wait, what?
Because they had like an early morning. I think the lit kids had like an early morning. Now we had the English.
Yeah.
Yeah, they had one and fucking just treated all of them a bit late.
Well, Mr. Lowe. It
Is number one card?
is
Is it?
yeah.
Let's test it.
Trust me, bro. You don't get it wrong when the human calculator makes this fun.
Well, we're getting our test back in like 5 minutes. So yeah, we'll see.
We'll see how the human.
Nah, bro, 100%. But calculating it, that's the game.
Alright,
Label the
I don't know, I just do it because it looks cool.
is this a bipartite graph?
Yes.
I think it helps if you label them.
It is
X.
because
X.
Told ya.
if you start off from 1, you can see
Yes,
that
it is, my dude. Yes, it is.
I have got opposite marker
Mark.
on all edges, and I can redraw that. It really doesn't matter in the exam if you draw it this way or if you flip it around. It really doesn't matter. Alright?
You're trying to distinct the two groups, make the two groups different. Yep. You want two different points of groups of points.
I can say that if you're doing better in your test, by all means, you can talk. If not, please keep your mouth shut. First, we are late. Alright, I don't blame you because of the test. Second, you come in, you chat non-stop. You're in year 12. I would suggest that some of you not sit together from next lesson onwards. And why is the laptop open? You are not supposed to use your laptop. That's the reason why you've got your what going on, and you've got to listen to this lesson. It's not the previous lesson or whatever. All right, come to exam style question. The table below shows which sports 3 friends, Joe, Haley, and David, played during their final year at school. Now, if you think about this, can you actually represent this as a bipartite graph or a type of graph? You don't know what it is. You know the sports: tennis, basketball, netball, football, cricket, and squash. And then you've got the 3 friends. So here, you've got, in fact, 2 groups. So let's call this tennis, basketball, netball, football, cricket, and squash. And then you've got Joe, Haley, and David. 2 distinct groups. So part A, you need to be able to draw a graph representing something like this. So let's start off with the sport: tennis, basketball, netball, football, cricket, and squash. All right? Tennis, basketball, netball, football, cricket, and squash. And then your 3 friends: Joe, Haley, and David. All right? So Joe plays tennis. 1 line. Now basketball, all 3 actually plays basketball. Netball, Haley is the only one. Football, I've got Joe and Haley. All right? Cricket, that's only David alone. And squash, that is David alone. Now, part B, they will ask you how you would justify, what type of graph is this and why? All right? This is not a complete bipartite graph because it's not all the ages are connected from each 2 groups. So you've got 2 distinct groups, but it's not a complete one. So this is a bipartite graph. You can, 2 groups can be identified. 2 distinct groups can be identified as the answer justification. Identify. And the groups
Yeah, man. Yeah.
are sports
Not complete, but 2 distinct groups.
and friends.
Bipartite.
All right. So that's how you could justify it. Think about
Sports.
question like this. Now, when you justify it, some of the explanation you all lost mark because of certain explanation in a couple of the questions. I will hand your test back now, and I'll go through that. I'll put this on Google Classroom in a few minutes.